Okay, today we're looking at the midpoint and the distance formulas. The midpoint formula comes from a basic idea that if I have 2 points, let's call the first point A, and I have a second point, let's call that point B, well, halfway between those 2 points right here, we will call that the midpoint. And the point A right here has two coordinates. The first coordinate as x and the second coordinate as y. And the point B has two coordinates. The first point as x2 and the second point as y2. And very simply, that if this right here is x1 and this right here is x2, well, the midpoint will be halfway between the two. And if this right here is y1 and this up here is y2, then the midpoint again will be halfway. My halfway doesn't seem to be very halfway. And so therefore that tells us that the formula has to be halfway between each. Well, the way we find something that's halfway between 2 points is by taking the average. And so your midpoint will simply be the average of the x's, x1 plus x2 divided by 2, and then the average of the y's, y1 plus y2 over 2, and that will give you the coordinates for the midpoint of your line segment. Now you can only find the midpoint of a line segment. A line itself extends forever in both directions and thus cannot have a midpoint. So you have to have a starting and an ending position for us to find the midpoint. So that is your midpoint formula right there. Second, we have the distance formula. The distance between 2 points comes from a very famous formula. So let's take this point right here, A. Again, A will have coordinates x1, y1. And a second point, B. And again, B will have coordinates x2, y2. In other words, it can be any numbers. This will work, doesn't matter what the points are right here. And I want to find the length from A to B. This point right here, again, is x1, so therefore this point right here is x2. This point right here is y1, and this point right here is y2. Well, what we recognized some time ago was that this right here can be seen as a right triangle. From here to here, and then from here to here. That's a right triangle right here. And there's this famous formula that relates the three sides of a right triangle. Is that the sum of the square of the two sides, a squared plus b squared, equals the square of the last side, the Pythagorean theorem. And by considering that theorem, I can go ahead and figure out what my distance is going to be. So this side right here is the length C, this side right here is the length A, and then this side right here is my length B. And based on my picture, A is the distance between these 2 points. Well, if you want to find the distance between, you need to subtract. And so A is going to be x2 minus x1. Similarly, B is going to be the distance between the two y values. See right here, this length is the same as this length. And so B is going to be that distance right here, and so B is going to be the difference. And so that is y2 minus y1. Now, so the length C can be given as c squared is equals to a squared plus b squared. And so therefore, c squared is equals to x2 minus x1 squared plus y2 minus y1 squared. Notice right here that I have changed the a, I have changed the b, and I've kept the plus sign between them. And since I want the distance and not the distance squared, I will square both sides. And that gives me that c is equals to the square root of x squared minus x1 squared plus y2 minus y1 squared. Because this is the distance formula, instead of using the letter C, we find it more appropriate to use the letter D. And so this is the formula we have, that the distance between 2 points is the x2 minus x1 squared plus your y2 minus your y1 squared right here. And that is your distance between 2 points. Let's take a simple example. Find the midpoint and the distance between, and then they give you 2 points. Let's say the point A is 3, 4 and the point B is negative 4, 12. And so midpoint MP, first I need to identify what am I working with. This is x1, this is x2, this is y1, this is y2. If you actually label those points in reverse, you actually will get the same answer, because the midpoint between A and B and the midpoint between B and A are the same thing, or is the same thing. And so again, I take the average of the x's, that's 3 plus negative 4 divided by 2, and then the average of the y's, so that's 4 plus 12 divided by 2. And so that translates into negative 1/2, comma, 4 plus 12 is 16, 16 divided by 2 is 8. And that's the midpoint between those two coordinates right here, negative 1/2, comma 8. The distance between the 2 points will be the square root of x2 minus x1 squared plus y2 minus y1 squared. Now we got to be careful with our signs. So that's the square root of negative 7 squared plus 8 squared. And so that's equals to the square root of 49 plus 64. And so that's the square root of 113. That answer does not simplify, so you can leave it as is. And that right here is the distance between my 2 points. Most of the time the distance will be a radical, and so it's important to remember how to reduce radicals. In this case right here, 113 is prime, so it does not reduce. But let's say I want to simplify the square root of 24. What you must do is you must first find the largest perfect square that divides into 24. Well, I can skip 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And the largest of these numbers that divide into 24 is the number 4. And so what I do is I rewrite based upon a number. Well, what two numbers multiply give me 24? The two numbers are 4 and 4 divided into 24 is 6. 6 times 4 is 24. Again, I'm choosing 4 because 4 is a number that's a perfect square. And so with that right here, since I'm taking the square root of 24, I take the square root of each piece. The square root of 4 is 2, and I cannot take the square root of 6. So the square root of 4 simplifies into 2 root 16. 2 root 6, not 16. Bad. Let's try again. Simplify the square root of 48. Let's take my list. Right here, and then let's keep going. I haven't gone past 48 yet. So 5, 6 squared is 36. 7 squared is 49. And I got to find the largest number that divides in 48. Well, 16 times 3 is 48. And so I rewrite this right here. Put the 16 first and the 3. 16 times 3 is 48. And because I'm taking a square root, take the square root of each piece. Square root of 16 is 4. Square root of 3 is 3. And so the answer is 4 radical 3. And there you go. I have reduced the radical 48. Just so that you know, if you made the mistake for 8 and used 4 instead of the 16, well, 4 times 12 is still 48. If I take the square root and I take the square root, I get 2 radical 12. What I must then notice, well, I can simplify 12, right? Because 12 is, again, 4 times 3. And so I can break this 12 down into 4 times 3 and then take the square root and the square root again. And that gives me 2 radical 3. Well, this 2 radical 3 is being multiplied by this 2 in front. And when I distribute my 2, 2 times 2 is 4. And of course I bring down my radical 3. And of course I get the same answer. This is called a repeated simplification right here. Whenever you break a radical down, you should make sure that the number you have right here cannot be divided by another prime, another perfect square. If it can be, then you can simplify your problem some more. That's the end of this section.